I hope everyone can be able to see this. Can
Yes.
give me a quick thumbs up. Okay, thank you. Thanks again for the introduction. My name is Andrew Mathu. I'm a member of the Azure Network Security CXC Customer Acceleration Team, and we are happy and excited that you've joined us for this webinar. Today, I'll be joined by my co-presenter, Tobi Otolorin, who is a teammate of mine in the same team. And we are looking forward to show you how you can protect your third-party applications, specifically GCP and AWS using Azure Web Application Firewall. In today's agenda, we'll go through a quick introduction. We'll show you about our resources, where they're located, where you can access them. We'll also go through an overview of Azure Web Application Firewall, and we'll also take a look at multi-cloud and hybrid cloud scenarios. In the second part, we'll take a look at how you can actually protect web applications in AWS and GCP. And these are the general steps that we are going to follow. We are going to deploy these web applications. We are going to deploy the application gateway with WAF. We publish these applications via the application gateway, and then we'll restrict access to these web applications so that they can only be accessed via the application gateway. So in this, you'll see it also in the demo. And then if we have time, we'll also have a question and answer through the chat. And that just also as a reminder, please give us your feedback. We have this feedback form. We appreciate your feedback. It helps in improving our future webinars. And also we receive feedback for our product feature enhancements. So to begin us off in this introduction section, I'll just begin with an overview of our Azure Network Security resources. Like I mentioned, we have the feedback form. Please feel free to add your feedback if you need, or if you have a feature improvement, or if you have a suggestion for future webinars. We also wanted to showcase our Ninja training. With this training, you're able to learn the basics of Azure Network Security products up to an advanced level. And when you pass an assessment, you get a certificate. So this is extremely useful if you are deploying, if you are working, if you want to understand more about our Azure Network Security products. We also have our GitHub repository, aka.ms/aznetsec. So within this repository, we have templates, we have workbooks, and these are useful when it comes to deployment of our network security products. So we also need your assistance in terms of contributions. You can go here if you're looking for a particular workbook. We have for firewall, for WAF, and this, of course, also you can share with your customers and also within your production environments to enhance your deployments. We also have our tech community, and within the tech community, this is where we amplify knowledge in the security community by sharing new public preview or generally available features, best practices, and common use cases. So within the tech community, we also publish our blogs, and actually this webinar is based upon some of our published blogs on protecting these third-party cloud applications. So this again is extremely useful in Azure Network Security. Finally, we also have our security webinars. You can be able to view upcoming webinars and also view recordings of past webinars. So these are part of our resources, and we welcome you to access these links and start interacting with them. So with that introduction based on our security resources, the next section will take a look at Azure WAF Overview, as this forms the basis for our webinar. So Azure Web Application Firewall, this is a cloud native service that protects web applications from common web hacking techniques such as SQL injections and also security vulnerabilities such as cross-site scripting. So Azure WAF provides best-in-class security services, and you can see them listed here. We have managed rule sets, and these are powered by Microsoft Threat Intelligence, and they protect against OWASP top 10 attacks. Like I mentioned, the SQL injections, the CSS attacks, and these are done through rules that are defined in the OWASP core rule sets and the default rule sets. We also have bot protection with Microsoft Threat Intelligence, and bot protection provides protection against malicious botnets, and it has the ability to block or log requests from known malicious IP addresses. We also have the ability to customize the web application file rules. So you can do this through a custom rules engine, and this will allow you to create your own rules that are evaluated against each request that passes through the WAF. And you can define these rules based on these parameters: geofiltering, IP addresses, which is IP description, HTTP parameters, and also a selection of size restrictions. We also have conditional rate limiting, and this is at the Azure network edge. So the rate limiting, you're able to control the number of requests allowed from a particular socket IP address towards the application, and this is during a rate limit duration. We have API protection, and this you can see is on JSON, XML, and multi-part support. We have DevOps integration with ARM, REST API, PowerShell, CLI, and Terraform. So you can easily build, deploy, and manage your application using DevOps and API-friendly tools. We have WAF Insights reports and also integration with Azure Monitor. And of course, you're able to view the web application file logs through the front door or through the application gateway. So this enables you to have visibility on what is happening within your web application firewall traffic logs. Finally, we also have Sentinel WAF connectors and workbooks. And with this, you're able to get what I can call deep integrated experiences with Sentinel, which is Microsoft's Cloud SIEM. And also, apart from that, you're able to deploy and integrate with Microsoft Defender for Cloud, Azure Policy, Azure Monitor, and of course, you'll have your metrics and logs for analysis. And then to finish it off, something to mention is that the above protections can be applied to hybrid clouds and multi-clouds. And this is part of what we are going to explore. You can have front door connecting to an on-premise through the application gateway and also express route. And also you can have the application gateway support for on-premise backend pools. So with these integrations and with WAF running on front door, which is what we call at the global level, and WAF running at the local level, regional level on application gateway, you're able to have comprehensive security, not only for within Azure, but also integration with other clouds and also with on-premises backends. And this again, will explore how you can be able to do that in the following sections. So with that introduction, I'm going to hand it off to my colleague Tobi, who will take us through the next section. So Tobi, over to you.
Hi everyone, my name is Tobi. I'm currently in Seattle, and thank you, Andrew. Also from the customer acceleration team. And as Andrew has mentioned earlier, during the course of this session, we tend to talk about the reason why you might need hybrid cloud or multi-cloud. In this instance, what are ways by which you can begin to design that? And if you already have that designed, what are the best ways to look into security, especially if if Azure is your significant main cloud. So basically taking advantage of resources that are currently available in Azure and leveraging it over resources that are in other third-party cloud environment. So, I mean, recently there's been a rise in different tech architecture between hybrid cloud and multi-cloud environment. Please, can you confirm that you can see my screen, Andrew?
I can't see it, Toby.
Okay, thank you, Gustavo. So hybrid cloud is when hybrid
Toby.
cloud.
Sorry,
Sorry,
Toby,
excuse me.
Actually, I can't see it. I cannot see it.
you need to share your screen, Toby.
Oh, okay.
Yes, we can see. Thanks.
Okay, thank you. So hybrid cloud usually happens when you have some of your infrastructure on-prem, and then you have some in the cloud space. This usually is the first step to migrating into cloud for most customers, because that way they can do it seamlessly. They look at applications that have low impact, that need low availability, and they begin to move with time. So, but over time, this also comes with some challenges. And some of the challenges that we find in hybrid cloud environment has always been you need an on-premise data center. You basically need to have real estate for it, which comes with cost, asset cost. It comes with management cost. It comes with lack of resilience, and also it can be impacted easily, for instance, by hurricanes and natural disasters. So there's a lack of oversight, there is reduced accessibility, there's reduced opportunity to scale as well. And then sometimes the configurations could be very, very complex, trying to create tunnels between your on-prem and your cloud environment. Sometimes there's lack of compatibility between the different interfaces to make connections. So it comes with different types of challenges. And then we also have the multi-cloud environment, where you have between 2 to 3 or more different cloud providers in your environment. This has more flexibility, gives you more availability. You can have different zone redundancy. There's improved performance. You don't have to reserve cloud instances. So when there's a need to scale, it scales, and when you need to scale in, it scales in. And some of the challenges that are in the on-prem situation have been addressed in multi-cloud, but it also comes with its own challenges, which we're going to be looking into shortly. But the most important thing is there's been a shift in how architectures are being deployed over the years. And as of 2019, about 56% of workloads are currently in the cloud space, with 7% being software as a service, and 29% being infrastructure as a service. So there's a lot of work being done in that space. People are coming up with different security tools, multi-factor authentication. People are coming up with automation tools, migration tools, things that just help you to move and make that migration seamless. So you can easily find a tool that will just let you compress data and then move that data from like a physical equipment to like your cloud environment. We have sandboxes, we have the different ways, we have express routes. We just have there are different technologies being built around making sure that there's seamless connectivity between your on-prem and your cloud environment, and making sure that with time you are able to seamlessly migrate and move your workload from on-prem to the cloud space. All right. What are the multi-cloud challenges and opportunities? I mean, some of these challenges, they present opportunities. So they are like a double-edged sword in some way. There's inconsistent and robust and lack of robust security offering. Now, this is something that we found in different ways. When you go online and you want to get a security product and you begin to do proof of concept, you try to get the different data sheets about different products. You can begin to see how one product works better than the other. What are the things you're looking for? What are the capabilities, and what are the items that are currently in development? Are they open source? Is it proprietary? Is there support? How many people are using? I mean, what is the testimony, or what is the customer story for those who are using it? And also, is there a centralized application security management? Customers want to be able to, in real time, manage what's going on in their environment. They want visibility. They want to be able to audit as need be, and they want to have visibility and knowing fully well that when an attack is occurring, they can gain access, understand what's going on, and reduce the attack surface area, thereby improving their security posture. Another thing is there's a need for a security, a pipeline for threat intelligence. There is the need to have your security database like complete continuously improved upon. So when you have threats and vulnerability landscape that involves constant development for the threat, then you need an atmosphere where you are sure that there are updates being provided, there are new signature IDs, and there's like every CVE is being updated in database, and you can be sure that your environment is completely protected. Also, logging and incident reporting. How is incident reporting handled by these different cloud providers? So the way people attend to live events tells how customers will react in terms of, do we want to renew this contract? Do we want to continue to work with this service provider or not? Because customers want to have over 99% availability, and when there is an attack or when there's an incident, they want to be sure that they're getting the best help that they can get in real time as soon as possible. Then also there's the problem of governance. This is super important because you need your governance, risk, and compliance to always meet all the baseline policies. So sometimes you have defined scope, and using different clouds sometimes means you have to make sure that you are able to apply the scope for your organization across the different cloud environment. And sometimes this is very, very hard to do. So it's always important that this is being looked into. If you have policies that you have created, say, okay, this is how you manage your environment. This is who can have access to it. It has to be least privilege. This is how we manage access management. You want to make sure that that is transferable across the different cloud as well. So when you have security baselines, when you have this governance policies all available, you want to make sure that that's available across all cloud. This is very, very important for auditing. And from a security perspective, this is completely non-negotiable. And then lastly, we also have the app deployment alignment. So sometimes when you look through your application security lifecycle, some of the things that are very, very important for your application's availability, sometimes they present difficult challenges to handle, and sometimes those are not technical problems per se. For instance, when you have vendor locking because your contract says you can only use a particular cloud, and the solution you're looking for is not available in that cloud, what do you do? And what is the ease of management? Is this very, very easy to manage? Can I automate some tools? Is this available as a provider in Terraform? Some things that make work seamlessly easy for developers, for security architects. Are these things available in this cloud? Regional availability, if you want to deploy in a particular region, do they have this cloud available there or not? So it's of things that are not even completely technical, but they are things that need to be considered when choosing what cloud you're going to use and what other cloud partners should you involve when doing your integration. All right. Okay, so what we have decided to do today is to show how we can use applications that we can deploy an application in another cloud, and in this case we have GCP and AWS. That's Amazon Web Service and Google Cloud. So we're going to be putting the applications in those cloud, and then we will use our WAF to do a test. So basically we deploy first, and then we make sure that we are able to publish those applications and they are only available via our app gateway. And then we would do a quick security test, basically launch an attack and see how WAF is able to prevent it. And then we will go through the logs to show you what the events that actually occurred. So I'm going to hand this back over to Andrew, who's going to take the first part. So Andrew is going to deploy an application in AWS real quick, and he's going to try to show you how you can use WAF to protect the application.
Okay, thank you, Tobi. Let me share my screen. Please let me know if you're able to see this.
Yes, we can see your screen.
Perfect. So as Tobi has mentioned, in this next section, we'll go through the demos. And in the demos, we'll showcase applications deployed in AWS Beanstalk and in the GCP App Engine. And these applications are being protected by Web Application Firewall running in our application gateway. So this highlights the topology of what we intend to do. So in the event that you have an attacker, of course, over the internet trying to access your application deployed in any of these other cloud environments, third-party clouds, you can be able to protect them through the Web Application Firewall. So you can see here this particular use case whereby somebody trying to attack these applications, but we have protection with Web Application Firewall. So of course, this is going to be stopped. Whereas if there's no protection, you do run that risk that these applications are going to be attacked and they will go down. So in terms of the general flow, we have the deployed web applications. We have deployed the Azure Application Gateway. This application is published through the application gateway. So actually for you to access the application, you go through the application gateway, and then we restrict access such that you can only access this through the application gateway. So anyone else trying to go directly to these applications is going to be stopped. So this is the general flow of the topology and of the demonstration. So for the demo part, I'll begin with AWS. And again, it follows the same process that I have described. So we'll deploy an application. In this case, it's called OWASP Brick, in AWS Beanstalk. We'll publish this application through the application gateway. We're going to restrict its access so that you only access it through the application gateway public IP address. We're going to test for application-based attacks, and then you're going to monitor these events in the diagnostic logs of the Web Application Firewall. So to start us off, I will go to my browser, and then just to note that this is based on this blog that you had published last year. The title is Azure WAF Protection for Third-Party Cloud Applications, and this was for AWS. So this gives us a step-by-step process of what we need to do, which application we need to download and deploy in AWS. We also discuss how you configure the application gateway with WAF and how you're able to protect and do a test scenario. So just to give a shout out that you can also be able to deploy and test this particular scenario by yourself and also demonstrate to your customers or to your teams. So to begin, also to continue, you'll see here, this is the actual application that we'll download and we'll upload into AWS Beanstalk. So it's within this blog, and the link is here for OWASP Brick. So it's called OWASP Brick. So here we have our AWS environment, specifically Elastic Beanstalk. This is the service for AWS for deploying web applications and services. You can see here I have one environment called OWASP Brick Application Env. The application name is OWASP Bricks Application, which is the application I downloaded and uploaded here. So once I've set this up, it will give me this URL, which I can try and access the application running. This is based on PHP. It's a pretty straightforward, simple application, and it's the one we are using for our testing purposes today. So to create a new environment or application is pretty straightforward. Just click Create Application to give you this page. In most cases, you'll just fill in a default name, an application name. So for mine, I can call it test. For most of these, you might leave as default the tags. Like I mentioned, our application is running on PHP. And then I uploaded my code, which I got from this site, OWASP Bricks. So once this is done, I create the application. So in our case, I won't go through this as it takes a bit of time, a couple of minutes, but I already have one pre-created. Once it's created, if you go inside the environment, you'll see here the environment variables. So it's showing our health is okay. The platform, like I mentioned, is running on PHP. One thing to note when we are creating this environment is that we need to give the location of the root file for AWS. In our case, that index root file is located in a folder called bricks. So you need to actually go to configuration, software, edit, and then add the path to that particular index file so that your application can work properly. So once the configuration has been done, that is our first step. We have configured our application in Elastic Beanstalk. The second step is we need to ensure that this traffic is going only through our Azure application gateway. And I'll jump to my application gateway, which is already configured within Azure. So you can see it's pretty straightforward. We have maintained most of the defaults. You get your public IP address, and of course you can see already there's some traffic that is going through it. In terms of the web application file, we have WAF version 2 running. And this is the name of my web application file policy, OWASP bricks WAF policy. We've left it with the defaults. So if you go to the managed rules, we are using CRS 3.2, bot manager rule set using the latest 1.0. We don't have any custom rules configured for now. But for the purposes of our test, this should be sufficient to stop any application-based attacks. In terms of the backend pools, this is an important configuration that we'll take a look at. So you'll see in terms of the target, it's OWASP bricks application, and this is the URL of the application that we set up in AWS. So in essence, we are pointing to that application through the application gateway. So once this is set up, the rest are pretty straightforward. We have our backend settings. So this is based on HTTP. We know this, and just to give a shout out to this, this is just for testing purposes. We're using port 80, and we know in a production environment, we should always use secure HTTPS. But for our testing, we'll go with port 80. We have our listeners listening for port 80 HTTP, our rules which have bound the listener and the backend settings. We also have diagnostic settings, so we'll send our logs to a log analytics workspace. And then finally, we also in the backend health, just to ensure that you are able to reach our AWS application, we'll load that and ensure that it's up and running. So you can see it's healthy and you're receiving a successful status code. So we have our application gateway and WAF setup. We have our AWS application setup. The third step now is to restrict access to this application and ensure that it's going through only our application gateway. And the way we've done that is through what we call security groups running in AWS. So if you are to go and search for security groups, this is a VPC construct in AWS, and they're used to restrict access to VPC-based resources and also applications. So I have here our security groups, and one of them, the top one here, is called OWASP bricks application env. And within this security group, you can see down here, we have an inbound rule. And this inbound rule really tells which traffic, controls which traffic can go towards our application. So what we've done, if I click on edit inbound rules, you'll see here, I have put the public IP address of the application gateway as the only IP address. So it means only this IP address can access our backend application. And you can see starting with 104, ending with 182. If I was to go back to my application gateway, I'll just click on overview. You'll see front-end public IP address 104, ending with 182. So in essence, we've restricted access to the application to only come through the application gateway. So nothing else is going to be allowed. And to do a quick test on this, if I go back to my environment, you'll see up here the URL of this particular application. If I click on it, it is not going to open. So this is just going to stay here because you're only allowing access to the application through our application gateway. However, I have another tab here. If I was to access this application through that public IP address on port 80, you can see our bricks application, and this is what we want to be accessing. So we have completed the third step, and now we have access to our application through our application gateway, which has a web application file running on it. So these are, in essence, the steps that we've done. You can also view them in the blog, how you're able to restrict access to this application. So the next step, like we had listed, is we want to do a couple of tests and ensure that you are truly protected against any application-based attacks. So I'll do a couple of quick tests. The first one is a path traversal test. So just append, or rather a path traversal attack. I'll just append this malicious code here to the end of our public IP address, which is the public IP address of the application gateway. You can see we're getting a 43 forbidden. I'll do the same. This time I'll use a code injection attack. So again, quickly append this piece of code. So we're getting a 43 forbidden, and this confirms this traffic is going through our application gateway. We'll also do a very quick third test. This is for SQL injection. I'll append these characters here. And again, you can see we are getting a block. So in essence, we're protecting an application running in AWS using our web application firewall. And finally, for monitoring, I'll quickly go to our logs. I had run this a bit earlier, but we can also see the results as they come in for the logs. So I'm running a query for Azure Diagnostics for application gateway firewall log. And I have here one of the malicious URIs. So this was actually the one for code injection. And if I look based on my time, this is the last one at 6:35 p.m. I have the block and I also have the matches. So this, of course, are also based on anomaly scoring. It got evaluated before it got blocked. I can also include the transaction ID quickly and then remove this so we can be able to see the actual matches and blocks. So I'll run this and see what it brings up. Sorry for that. But in essence, we are able here to see the matches and the blocks that we've gotten. For example, this is my last one that I did for SQL. I'll try that again quickly. And here you can be able to see the actual matches and blocks. So this proves that our application is in AWS is protected. Great. So with that on the AWS side, I am going to hand it over to Tobi, who will take us through the GCP setup. So Tobi, the floor is yours.
Thanks, Andrew. Please let me know when you can see my screen. Andrew has done a very great job, so I will try to minimize time. Thanks, Andrew. And he walked us through how to set up the app gateway part, and he also walked us through how to read the logs, sorry. Like you mentioned, we have a blog post about this webinar that's available. My teammates will be sharing that in the chat. Please feel free to use the blog. There's more detailed step-by-step that you can follow to get things done. All right, I'm going to do something very similar to what Andrew just did. Sorry, excuse me. I'm going to do something very similar to what Andrew just did in AWS. So I'm going to be using GCP environment. So in my case, I have my GCP environment here, and the few steps that Andrew has mentioned, I'll be following something similar. If you can see my screen, Andrew, please can you confirm that you can see my screen?
Yes, Tobi, I can see it
So
clearly.
I have put my steps. Thank you. I have put my steps right here in this notepad. So please try to follow along. The first part is I have a coffee shop application, and I want to give a shout out to this person here, Baltasar Hofer. I found this database online where it just had like tables of different types of coffee from different parts of the world. And I thought this was a very, very good table. So I was able to use that database in my application. So the first thing I will do is I will deploy a coffee shop application in GCP. To reduce the time, I have already deployed that application, but to deploy the application, the very few steps that I would have to take is to create an app engine, which I actually did by just going to App Engine. And when you come here, if it's your first time, you'll see the opportunity to create one, but I already did. You only need two parameters, which is what name do you want your app to be? I called my sample application GCP. I mean, I'm that lazy. And then what region do you want it to be? I mean, Seattle, which is Pacific Northwest. So I chose US West too. So those are the only two things basically needed to start an app engine. Now, the next step would be after starting my app engine, I need to upload my database I need to upload my code into the app engine. Of course, again, I have done that as well. And the next step for me was to upload database to Cloud Bucket. So I already have this database. It's available in our network security, in our GitHub. That's like Andrew mentioned earlier, it's aka.ms/az-netsec. So please feel free to go there. But what the table looks like, they are very, very simple tables, just showing coffee, showing the people who have users to this application. And so this is the coffee application right here. And in this folder is a coffee database. If I actually open it up, you can see it's just different types of coffee in there from different parts of the world. So I was just fascinated by that, and I thought it was pretty good. And you can see some users in there as well. So I've already done that. So to show you how to do that was pretty straightforward. I just went to my cloud storage and I went to my bucket. So in my cloud storage bucket, those three files I just showed to you, my coffee data, my create database, and my users, I upload them in my bucket. So in my sample app GCP bucket, you can find those here, which I just did by uploading those files. So I have uploaded them. Then the next thing is, how do I connect my front end of my application to my back end, which is this database? So I need to connect database to my SQL. Again, straightforward. I came to SQL here, and I was able to create a SQL instance called Coffee Shop. So I put some steps into how to make sure that works. There are a couple of files that you have to edit. I've already put those in there, but you can always go to your Cloud Shell as well. And you can just use the terminal to do that. And you can test your connectivity and make sure that it works. For me, it was pretty straightforward. I could always connect to it and make sure that I have my application running. So my application is right here. And if I do this, so excuse me. All right, so if I just tell it to connect to my SQL environment. Sorry, excuse me. Oh, G-Cloud. SQL connect to Coffee Shop. Okay, so of course I'm going to be asked to be authorized, and I'm going to authorize myself, and now I'm in my SQL. So it's going to take a couple of minutes for that to load. But again, just back to my overview, I can show you what the application looks like when it's done. So if I come back to my app engine, now we follow all the steps that I mentioned in my notepad. And what the application looks like after deploying that, it looks like this. Sorry, this is still loading on in there. Okay, so I have my application, and this is what my application looks like right here. My online coffee shop. So you can see my sample app at GCP is, and because my once my SQL finishes loading, okay. All right, so I can, if I do a refresh here, I can see all my data. So you can see all my coffee and all of that. And if I want to see dark coffee, just dark, I can filter for it. So I have my application running just fine, and I can see all what should happen. So that's my step one. I've been able to deploy my application in GCP, which is everything that we are going to is the blog. So you can follow the step by step. You can try it out, pretty straightforward. Now, the next step is I need to add this application to the back end of the app gateway. So the same thing that Andrew did. I have my app gateway here. And if I go to my backend pools, I've already added it here. So right here, so you can see the same application sample app in gcp.appspot.com, which is the same application that I have here. Sorry, here. I've added it to my backend in my application gateway. So now the next step is, so now that means I can try and make sure that I can get access to it via the app gateway's public IP address. So you can go to the app gateway's public IP address right here, and I copy that public IP address, and so now from the public IP of the app gateway, I can access my GCP application. So the next thing we want to do is now we don't want access directly to this application anymore from this URL. We need to restrict it and make sure that the application, the connection only comes from this public IP, which we can always, use a rewrite, either rewrite to just have it, give it a name for customers to use in-house. So, but like I mentioned earlier, you don't want customers to go directly to this application, because going directly to this application in GCP might be vulnerable to some things because we are not using WAF yet. But if you go through here, because of the app gateway, there's a WAF that's currently being configured in the app gateway that you can use. So you can find our WAF in the app gateway here. So how do we do the restriction? We come to our app gateway, and we go to GCP. And then first of all, we can come here, and then we can go to a second here. So we go to the firewall rule of the app engine. So if I go to my app engine, second. Okay, so if I go to my firewall rules in app engine, now this is in GCP. I can come here, same thing that you did in like you did in AWS. I can create a rule. Now I am going to create a rule. Right now it's allowed. So I created this while I was testing yesterday. It's allowed. So I'm allowing this rule to come connections, and I've given the priority of 100. So without this rule being there, what you're going to have when you come here is this default allow, because this is a reverse. I mean, this is an application in layer 7. All applications, all incoming requests are allowed by default, except you specify that you don't want those. So by default, all connectivity is allowed. So what we need to do is create a new rule. And then in my new rule, I'm going to give it a priority, as long as it should be lower than the default priority. So I'm just going to give it 100, which is lower than the random large number that's in the default one. And then I'm going to allow it, and I'm going to use my public IP of my app gateway to say this is the only connection that you should accept. So this is the only connection that you should accept. It's going to be a /32 because of the app gateway, and I can just give it a name, app gateway public IP. All right, and I can save that. Now, when I save that, this is still allowed, so I have to come back to this one and then deny all on it. So now this is the default rule. By doing this, I've now denied every other person except every other request except the app gateway's public IP address. So by doing this, once this takes effect, I can call back to my application. And if I do a refresh now, I am forbidden because the app gateway, the rule that I've set up is now forbidding it. Now, all I've just done is I'm just allowing this connection to come from the app gateway, and I'm restricting access. on the GCP. So now that I can now focus on my app gateway, I can now say, okay, what do I want to do in my app gateway? That's the next step. I have my application ready. It's not accessible via the direct connectivity, or it's accessible via app gateway. Now I can then go to my WAF and then create rules. So if I go to my WAF, Web Application Firewall, I can look at the rules available. I can create a custom rule. I can, look through my managed rule sets. Again, Andrew spent some time on this, so I'm not going to spend some time here. But now I can do a test, which would have been permissible when I didn't block this access. So let's do a quick test. I have a script here that's supposed to deface my application. So this script, I can just copy the script right here, and I can insert it in one of my text boxes to take an input to my database at the back end. So this script is a cross-site script, and it's very simple. And basically, if I put it in my application in here, same way I searched for dark the other minute ago, and I filter for it, my app gateway is able to block it because it's able to see that script is a malicious one, and I'm trying to deface this website. If I take that rule out of my firewall rule and I remove my app, if I allow everybody such that my connection is permitted again, now I have now if I refresh, I have my connection back again directly. Now this app, I'm going directly to the application, and I don't have the WAF protecting this site right now in GCP. So if I insert the same, the same scripts that I just copied and I paste it in there, this is what I get because I have this, it's supposed to be boss character catching vector that I'm inserting, and that's what is going to return. So that exactly is how having that application just sitting there in Google and just publishing the application directly, it opens you up to scripts like this defacing the website. However, when you go through here, you're completely protected by the app gateway. And again, like Andrew showed, we also have workbooks, so you can take advantage of workbook in the same repository. And you see, if you go to WAF, there are two workbooks in there that you can take advantage of. There's the WAF monitor workbook, and there's the app gateway triage workbook. Both of them are very, very useful depending on how familiar you are with workbooks. There are instructions to follow. We spent more time in the blog post, so please feel free to take advantage of that. If I also go into the logs, like Andrew did, we're almost at the top of the hour already, so I'm not going to spend too much time there. But I'm glad I just spent some time in there. But if you wanted to, we could go into the logs as well. All right, so I'm just going to copy my query real quick, and I can search for what I just did now. It happened in the last 30 minutes, I believe, so we should be good. I mean, it might take a couple of minutes to run that. But while that is running, I just wanted us to make sure that we've covered most of the bases. So yeah, that's step 4, and then step 5 is lookup monitoring. Excuse me. So again, like Andrew did, I can come in here and I can check what's going on in my environment, and I can see the different things happening, the bots, the protocol enforcement. I can see what the attacks happening that's going on in my environment, and I can keep checking this. And you will eventually see what's going on in your environment. You begin to see all the scripts, everything that's been trying to send into your that's been sent into your environment. So this exactly is how you follow these steps to protect application in your GCP environment. So I'm not going to take the rest of the time. I'm just going to go back and Andrew send it back to Andrew to let me know if we have questions based on things we've discussed today. Andrew?
Thanks, Tobi, for that. I appreciate it. So I think most of the questions were handled in chat, unless maybe there are some we haven't seen. Jason, I don't know if there's something you want to add.
The team has been great with answering all the questions. We do have a
couple here at the end. What about the cost regarding the traffic between Azure WAF / app GW and the resources in AWS / GCP?
I'm not sure if I get the question. So different cloud have different price model for their applications. Most applications also, it's also depending on what kind of application it is. Does it have cold data, or is it hot data? Is it dynamic website? Is it static website? Is it what kind of what do you also interface in the application? Do you have access to storage, or are you just serving one-page content? Do you, for instance, Andrew's application in AWS was just in Beanstalk, and it just had about 3 or 4 pages. It didn't have to load any SQL in there. I mean, it could if you wanted to. The GCP one, I was able to load some data into it. It's not too large, but it's still some database. So in the GCP, we used storage, and we also open MySQL. So I feel like it's distributed. But if it's in terms of data, in terms of traffic, now in our in Azure, we have some interesting price model, which I think please feel free to reach out to your technical your TA, your technical account manager or your sales manager to get more information. But right now, because we're very, very passionate about our protection, if you are working with, if you have DDoS and WAF together, WAF is mostly free because you're using it with DDoS. So there's like a package that comes with that. So it's almost little to no cost to use WAF when you have DDoS protection as well. Without DDoS protection, it's also minimal. So again, because it's based on your match, there's a match factor. There is also WAF is a security component here. There's also the actual app delivery platform you're using, which is the app gateway or the front door. And that reminds me, I almost forgot. People always ask me that, Tobi, this is app gateway. If I want to restrict access in front door as well, how do I do that? And I've always wanted to mention that. So I think what you can do is, if you go to your app, your application, let's say it's an ASE or whatever, or in Azure, you can go to the application and then you can go to the networking, and under the networking, you will see a service tag for Azure front door. So it's going to be an Azure front door service tag. We also have the documentation. We've updated our blog to have that information as well. So back to the question again. The cost again, like I said, it varies. What kind of architecture do you have? What kind of app are you using? What kind of app resources are being used? And also there's the bundle, like I mentioned, when you have DDoS plus WAF, which is like almost non-existent for WAF in that scenario. Well, I'm sure the sales team and the marketing, the sales team and the terms can provide more information on that. I hope that answered a little bit. I hope I try my best with that.
Great. Thank you so much. That seems to be all the questions that were left unanswered. So with that, I'd like to thank you, Andrew and Tobi, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/AzureNetSecFeedback. Thank you and see you next time. Goodbye.